Good morning. Everybody have a cup of coffee?
Yep.
Good. So we're halfway on the road, right? Well, first of all, I'd like to thank you for allowing me to share what we think is another generation of way to identify and accurately, effectively take a look at a variety of versions of cyber attacks. And bringing this in home closer is actually into the VM world and where it would fit in those areas. Now, I'll share with you that we can go as deep as kind of you would like to, but if I kind of become a little general, there are some intellectual property issues that might raise their heads. So it's not that I'm trying to avoid it. We'd be more than happy to have a more detailed discussion in more of a one-on-one basis, if you will. So please, at some points in time, bear with me on that. We're out of Minneapolis, and yes, there is 4 distinct seasons, and it does get to 90-some degrees, which it has been. And so we have a bunch of people that like to stay inside during the winter and code. So we're also kind of the home of Cray Research and some large mainframes, which has certain variety of expertise that we can bring forward. So at any point in time, if you've got some questions, make it interactive. Love to field them and start a good collaborative discussion. And it's really, again, evolved around the real basic concept of how do you, one, find a method to stop today's attacks. And today's attacks are no longer just part of a network. They're espionage, they're sabotage, they're hackerism, all of it. So, you know, we've had a cold reality when the electric world all of a sudden realized the stucknecks can take care of some of the control pieces. And as that control piece becomes part, they're now integrated part. An interesting opportunity I had to speak in front of some of the electric associations and some of the electric companies. The very thing of change factor is really kind of an interesting thing. You go into their organization and you talk to the IT people, and the IT people go, yeah, I know about these things, and we're doing certain things, right? Normal network stuff. You go to the control area, the SCADA people, and they go, I'm scared because it's becoming network-based. So we're having a complete crossover and a retooling of some of the skill sets in the two areas. But it also is kind of why some of these things linger, because some don't understand the other person's role. And that's an underlining piece to all of that. So in the world of cyber attacks, it's not just the data networks anymore. It also now becomes voice over IP, because the call manager, all those type of things are vulnerable and can be used. And what they're really trying to do is find an internal platform they can land so they can go horizontal. So voice over IP is well in the mix of it. Closed caption, IPTV, IP video, etc. Not many people talk about it, but it's actually now a piece that is becoming front and center with all the visualization, YouTube, and you name it. There's a lot of pieces, just like anything else. There is a payload that is not always full. There's always a process that's always there, but nobody was looking. So it's also become a target of attack. And as you start investigating and looking at some of these pieces, you start finding that there's actually some activity, a lot of activity going on that you just plain didn't even think or realize. So VM, where it fits, is what used to be thought secure is no longer secure as well. So at the end of the day, every endpoint, everybody's part of the problem. You have to be part of the solution to be able to help and identify and stop and not let these things go forward. So the underlying driving force of all this is it doesn't matter which vendor, which process, and et cetera that goes on, that the reality becomes the number of attacks are increasing, the effectiveness is going down because they become more strategic, and now we end up with things like UltraSurf. Everybody know what UltraSurf is? Okay. UltraSurf was designed, and you can jot it down and look it up. UltraSurf, like Tor, like some of the other pieces, they're using in parts of the structure to be able to hide what they're doing and who they are. What it was designed for is for people in third world countries, particularly China and some of the other countries that were being censored, so they could be blocked to go to the internet. They couldn't go to only but certain sites. So their civil liberties, freedoms were being interrupted. So there was a group that said, we can do this. They named it UltraSurf. You can download it. It's free. And what it does, it gets around every list-based system there is. The other part is, you can't track it. So you can sit in China, get on, and now go to other parts that were normally censored, get around, and they can't find you. Now, because it's free, people and students, we find, well, it was where I first noticed it, in K through 12 in colleges, they're downloading it, and they're getting around all the filters that they're putting, everybody's putting on just to get to their favorite bad sites, or whether it's Playboy or whether it's some other type of things. So it becomes a real challenge of how do you identify these things. And of course, every day there's a new type of attack, there's a new type of structure to it. So getting around, it's like a cat and mouse. So we end up with another aspect that's going on is, can we turn human in aspects of looking for viruses, looking for the type of malware, whatever you call it, can identify it with the humans and continue to do that. Today's days with speed and et cetera, you can't do that anymore. We're reaching the point where automation is going to have to take over. We've been there, but it's a matter of, in some organizations, it's very tough for some to give up that control. But in the end of the day, when you're dealing with something like this, is can you find it quick? Now you've got the tools and you put it aside, but security is becoming to the point where it's integrated into the network, integrated to everything. So it's a matter of not, people want to be secure, but they don't want to infringe on their user rights and their ability to have free-flowing information. So that is predominantly what they're looking for, and hold to that very staunchly. So the real piece of what's happening is all these things mutate. And we'll get some examples here in a bit. But the whole piece of mutating. And so now that you have a list-based system that says, I've identified this and I know how to block it, and they send it out to the world, and next thing you know, it's blocked. But with mutations going on at the speeds that they're doing, you can no longer have a complete list-based system. So the art of intelligence, or something, some methodology to be able to identify very accurately and effective in real time whether this is an attack or whether it should be allowed. And some will say it's like finding the needle in the haystack. Well, that's kind of true, because these things are no longer just the big X anymore. They have a tendency to be just a couple of events. They'll lay dormant and pop up again. So it's a matter of how the process to be able to identify these things and remember along the way, and so that you'll be able to catch it when it's there and be very accurate. When we go down the path of being secure, some of the things we have to get rid of, and some of those the old myths that come out. And myths is that I will check my logs and change the rules. Okay, you can do that daily, you can do that hourly. Even phantom websites today are now mutating to less than 4 days. Will change addressing and locations every day. So what used to be something staying for years is now mutating and changing location, style, etc. every day, and probably soon every hour. So now how do we go ahead and do that? So you change the rules and logs, that's part of the process, but you have to move these things into a real-time environment. I can protect with a firewall. Well, I don't need to, a firewall only inspects certain aspects. And it drops, but it doesn't remember. So there's some other pieces of all this to help go forward with it. In the particular point solutions, you'll have an IDS and IDP, and you'll have all these things in every environment that there is. So they actually be able to identify known events, but you have to know them. And an IDS looks at certain components or certain script sets, et cetera, all up and down the layers. Encryption. Now, some of this may sound like just, that's just the age-old thing. That's what we do. Each one of these are pieces that have been solved the problem along the way, and that and gotten better, but we've also found that people have gotten around them in certain areas. So depending on what kind of encryption component that's in place, with today's inspection and redistribution in the internet, somebody can hack the code and send it off, and next thing you know, everybody is doing that. So we've got to be able to, again, move a little bit further. Patching. It's a good step, but again, knowing real time. It helps part of the problem, but it doesn't solve the whole thing. Deep packet inspection. I love the marketing pieces. Deep packet inspection. Has anybody ever asked how deep is deep? Everybody uses deep packet inspection. How deep is deep? You go to the payload? Do you do all the payload? What parts of it? So ask the tough questions. Outsourcing. Outsourcing may or may not be more secure. Read the SLAs. Some of these things are changing because it's now becoming basically an insurance policy and skirting the real issue. Now maybe the tool sets and maybe the skill sets aren't there, and that's great. It's an improvement. But make sure you look at the SLAs and et cetera that goes with it. And VM is secure. Well, as we all learn, it's just like everything else. There are vulnerabilities in the whole process. So as this thing moves on, everybody started going around, and we had a time frame. Everything got better. Attackers got more sophisticated, and et cetera. And next thing you know, you have UTM, which put everything on one device. Good step. Not the end game. And then you had next generation firewalls, which were basically looking at all 7 layers in the OS. In this particular case, it's in the operating system. So the application layer. Sandboxing, which is prevalent in the VM world, you end up having it pulls it across, and it can do some investigative work, et cetera. But none are really quite real time. So what I think is going to happen is there's going to have to be, again, the force into real time. And all of this is the point is leading up to what intelligence is about and why intelligence, whether it's regardless of who it is, the concept and the process of using real-time intelligence makes a lot of sense. So a lot of money spent, and we continue up. Polymorphic attacks, I mentioned UltraSurf, all these things. And quite frankly, I kind of think at some point in time, it's going to be the war of algorithms between the applications and the attackers. So they're going to see which algorithm at what time wins. So it'd be ping pong back and forth. But anyway, so those things will probably happen. So malware's always started out as really kind of had a certain definition, but it's really become a process because some of the actions that go on in today's malware is slightly different. It's more enhanced, but it's also taking on characteristics of what used to be an APT. So there's also kind of a combination of a process going on here. It's consolidation. So now things are changing to get around the defenses that are there, find ways around it, so they try something else. Well, that has attributes of something that was known as an APT, Advanced Persistent Threat, or it had attributes of a Trojan or those type of things. So those attributes are starting to show up in a lot of different ways, and the naming conventions are kind of getting to the point where they have a generality to them, and then we still have to drill down into the specifics. So even in the VM world, cross-site channel, desktop virtual users, sandbox applications have been. So now how can we turn all of these things into a real-time learning device? In the complete operating system of the VM, really there are, again, whether it's a rootkit sitting somewhere or a red pill, it's all about being able to inject some piece of code somewhere in the layers to be able to identify and circumvent what has already been there, a process or a protection against it. And in some cases turn it against themselves or use it to get further and then send out what the real target is. No big deal. I mean, I'm sure you're all aware of that. But it's each one of these individually that continue to go through and they find individual little cases. So how can we actually, by using some of these as clues, can we now be able to use that and see what's going on and analyze it in real time and then present a defense that is identifies accurately and effectively that type of behavior. So every one of these, just like the application areas above them, whether it's Windows or the operating system Linux, they all have certain vulnerabilities and et cetera. And we're learning more and more about these things, and everybody finds something new just about every day. So as that happens, it gets put out in the community, no big deal, we all know that. But again, we have to go back and figure out how can we, in real time, stop it so it doesn't continue on. In any attack, there's always a certain set of priorities, certain set of flow patterns. And recon. Everybody comes in and tries to, the big X days are gone. So we end up having the biggest recon so we can look at different things, but we have to have certain inspection points in place to be able to catch that. Okay, so we end up with various VM tools. We can look at register keys. We can use as the various locations and interrupts happen and take place. We can use that as sensors to learn what is happening and the move and the change factors that go on. We can change how the interaction between the guest memory versus the real machine memory and their allocations and their in the processors themselves. We can take the differences. So if we see anomaly behavior, and there's a vertical market anomalous behavior. So whether it's supposed to sit in a certain location in a certain part of the register, if it changes, if it's above a certain memory allocation, 0xFF, if it's above or below, that might mean something. So with a reasonable doubt or reasonable understanding, we could actually take and say, we probably know, or the attackers are knowing whether you're using a particular operating system, and then they know the vulnerabilities. So if we know and scan and see these people doing these things and find the control piece, we might be able to understand and learn what they're doing and do this in real time. We can also take a part of aspects of the correspondence and the communication path and communication channels inside. So we're looking at the NIC cards or MAC addresses and the schemes with the MAC address. We can see if there's a USB and the controller types, those type of things. And audio adapters. So everything for clues, even system clocks. So if we can find, again, learn some of the very basics, which is always out there, but if we can learn the behavioral piece, we can actually use algorithms to be able to determine and detect this and be very accurate. So we're moving to an automated state instead of just a human state. We can take a look at shell scripts and how they interact and what those are done, so that certain aspects of an attack will have a certain script. Well, they may change a different script later on. But if we remember it and identify it and we use the algorithms, again, it's just another clue. So part of the whole piece of all this is there's a lot of components that we can use for clues. And whether it's file sharing, time synchronization, etc., again, they're all part of the clues. And timing, synchronization, clocking, how it reacts with ICP, TCP, the particular ID values. We can look at patterns in the packets, where they fit, how they're transcribing, how the channels are set up, the movement channels between, the flow between the application and various parts of the VMware. One of the fears and pieces that are starting to happen, and it's been going on for a bit, but it's a matter of escaping. So if you can imagine all the large shared data centers in a VM world, is can you now take that guest VM and move it and slide it to another guest? So the horizontal movement is starting to happen even inside not just VM but also in organizational structures. For example, we have witnessed where an APT has come in, circumvented all the different security processes they've had, and walked in, and next thing you know, became a landing spot. And now within normal communication inside the organization, you're starting to see movements of information of odd behavior, catching information between departments, between PCs, servers, and et cetera, and then eventually certain little pieces of information going in and out, in and out. But they circumvent it and be able to get by the traditional. So by using it in the network layer, the VM piece, we can use that layer as a section to identify and see some of this movement that goes on, and then we can learn from it.
So picking up on that point, are you seeing what traditionally was, if you're on the LAN, you're trusted, changing? So specifically to VDI, if I've got a user that is now a VDI user, you're on the LAN, you're a trusted user, but now I've got east-west traffic that I need to be concerned with. What, from a network perspective, is out there today that can knit who to what? So we're seeing a problem of, if I want to do east-west security, I've got the BSG, but that's MAC-based security. I've got ICE from Cisco, that's who, but ICE doesn't work inside a VDI environment. What knits those two together?
It's becoming intelligence, some type of intelligence piece will be that knit and that cohesive glue. Now there are components to that. So traditional, an MBA, Network Behavioral Analysis System, a SIM, Security Information Event Log Management System, which really had the communication path and understanding between various devices, okay? So now that you have, to get the communication and understand what is normal communication horizontally within an organization, between, whether it's between protocols, whether it's between processes, with, you know, whatever layer you're looking at, so that they understand there's that communication path. Then learning from it, and then pieces that will be able to identify that traffic and either block, alert, or block, et cetera. So there's a step in there that the intelligence would be part of that. There are components that are somewhat there, but you know, the concept of a learning SIM is not quite there.
Okay, so is that going to be, in your mind, an emerging third-party market that's going to take that and just parse logs and understand that and bring those two hardware-based versus person-based together?
The whole concept, what's happened in networking from a historical standpoint, it's always about convergence. The funny part becomes is what converges with what. Generally, you start out with a particular situation. I solve a problem, I have a problem, I solve it. It becomes a $300 million market. It's vertically siloed. Next thing you know, well, how can I enhance this? Okay, so now the next feature becomes maybe the silo next door. So now convergence happens. Okay, let's do, for example, let's take acceleration. I think of a web acceleration, whether it's whatever vendor you take a look at. And what they do is accelerate. They're doing some caching. They're doing some those type of things, right? So in essence, if you're doing just that, should you add security? You know, I think of also traffic shaping. Packeteer a lot. Do a great job. Okay? However, what they're doing is traffic shaping. So is there a place for security to be added into traffic shaping? And so what kind of security does that come into? For us, I'll insert here, we do that. And we do a lot of those things internally. But we use them, we look at them as clues to a lot of things. Certain parts of this have been commoditized. They're always a neat feature and et cetera that goes on, and there's some stellar companies. But I think they become a clue. So somebody tries to alter or change, they want their YouTube to go in faster, or because they have a bigger block or a bigger size file from et cetera to download. Could they, in essence, turn off AV? Could they, in essence, change the quality of service components and configuration for this to come through and then shut it down when they're gone? Those type of things. So at some point, all of these things have got to have that threshold, and I'll talk about thresholds a bit, but also the intelligence to understand, should that or not be allowed type of thing. So it takes inspection, it takes that together. Does that answer your question? I think so. Okay. Any others?
Yeah, over here.
Yeah.
Maybe a comment to your question. For me, I like VDI users, though, as they live in userland. So whatever that is, outside your firewall, DMZ, whatever you call that. So a user in a VDI session has the same sort of network protection, whatever that means for you, as some random person off the street getting on your Wi-Fi. And so if you have the mentality of whatever you're doing to protect your network from your users and vice versa, you have the mentality, you treat your VDI servers and RDSH servers as desktops, then put them in the same location and run the same tools there that you do for all the desktops and laptops in your company.
Mm-hmm. And until recently, I mean, some of the power of the processes, et cetera, could not come down to the desktop level to be able to handle a lot of that, because it still comes down to speed and performance, and user I don't want to wait. So those days are here. And it really goes on the same version of borderless security. I mean, the borders are down. However, every entry point, this is where I disagree a bit, but every entry point or exit point is a potential for a landing spot or an entry point for an attack. So it's another point for an inspection point. You don't really know where that's going to show up. You don't really know where that is going to be inserting something, or a man in the middle changes it all. So now you redirect it at the speeds we're doing on in the world today on the internet. You can actually you redirect, inspect, take a look what the characteristics you're looking for. Payloads are never always full, so you can inject and the application stays running. So borderless is, to me, has some qualifications to it. It doesn't mean you just don't inspect at the border, because at that point, you still want to be able to have the ability to block it before it comes in, as opposed to landing internally into a mail server or an app server or something like that. Because maybe it comes in through the call manager, or the PBX, the VoIP system, or as I said, video conferencing systems. We've sat behind video conferencing system, and the voice and the data, we have found attacks that become an entry point. So, any other questions?
Just a comment, so just to pick up on this, also this rootkit issue. So I guess what you're saying is that the attacks increasingly entering your network from the endpoints, right? So there's really the core focus on endpoint protection, with critical elements such as automation, for example. We don't have sufficient automation frameworks here today, and then we need elements such as root of trust, right, to secure endpoints properly. I think that really goes a long way, and so that's also actually part of my session tomorrow.
Okay. Good.
Process of endpoint security from, I gave you like a Cisco Pi server
important elements actually that presently also evaluated in various standardization groups. But I mean, VDI is actually an interesting challenge all on its own. But you're right. I mean, electromagnetic is only one element actually. So the way we actually must address these problems is by mapping, all the various elements closer into one strategy, into one security architecture. So that would be, one of my part of my presentation tomorrow morning.
Mm-hmm. Would agree. Yeah, there are a few pieces that still have to come together. Absolutely. Absolutely. What I can say, though, when we start going down this path, there are pieces that will be able to become better. We're already in the process of getting better at identifying and see the overall ability to identify some of these strange behavioral things that go on. So it's like everything. It's a general, consistently gets a little better. In the operating system, it's very similar. We'll hit the VM side of it in a bit here, but the point is every one of those, and a common theme that's happened in developing security strategies as well as protections is everybody would go out, there'd be a problem, they'd go out and say, look, I'm going to solve that problem. So they've had to identify it and then find the solution and then redistribute it to everybody. And that was good when you didn't have real-time variations and mutations that go on. It was good when things didn't happen, maybe it happened once every 3 months kind of thing. But as that escalated and speeds got faster, it becomes insufficient. So, but we've also, the holy grail to this is every one of these attacks now, in those vulnerabilities, now have had these processes, and we've moved up the scale to where the app layer 7, has now been validated that it's just part of the inspection piece. That's really what next generation firewall was about, is putting that into the whole aspect of it. And so what everybody did is, well, the attackers didn't, well, we've got HTTP attacks, we've got spoofing, and all of those that go on in every one of those layers. So, but if we're going to use the malware and the extensive use of malware in a broad sense, they start taking in processes that may or may not take in any one of those areas. So to be able to effectively and accurate, we have to have sensors that kind of detect all that stuff. And of course, then everybody's put together some form of protection to identify it along the way. The last being web application firewall. So we look at the GET requests and things like that and change. Where an IDS and scripts may not be able to be good enough for it. You may catch part of it, but you may not catch all of it. So it's a matter of putting it all together. SIM, to your question again, use it as SIM comes out, and you have an overall layer of looking internally, secure information event management, so using logs, taking a look at everything. And the question is, once it's blocked, or if it has blocked something, it never remembers anything. So how do you stop mutation? And that's, what I see, that's the common theme, is one of the last pieces of stopping the mutation part. Network access, and you mentioned it as also as part of your question as well. Network access control startup. It was very similar to that. That's being at that about $200, $300 million, and okay, now what? So you do an access control, user, check is somebody comes on, they were put in mostly guest networks or combination, but now found themselves, almost died, and all of a sudden coming back because now it's an endpoint protection. And even some of the functionality is now showing up in BYOD. Exactly. So the functions were core, now sometimes expand out a bit. So for example, in NAC, continue on, network access control. They check and see, oh, do I have an antivirus? Is your firewall on? Your operating system is patched. If it doesn't meet my admin criteria, I drop, you don't get on. I'll send you automatically to a particular site, and whatever AV client you're using, in this case, it'll download the patches, download the updates, tell you, okay, now try again. All automatic. So again, another theme, automation, not injecting human intervention to this. So now you've become, the mobile world can actually have a secure place. Again, another step forward, but it wasn't the end game, it was at the client side in that particular thing. So in every one of these, the pieces where the malware, or even denial of service attack, and I'll hit another piece here a bit, but they've all changed, and again, much like the example with NAC and SIM, is they now take common functionality they had and broadening out, so they really become very broad. Things, parts of an APT have looks like a malware, what used to be old malware, but there's various processes that have changed throughout the whole time frame. Being able to check for CNC, for botnets. It doesn't always go on the same channel. It doesn't always have the same pattern. It's found in other aspects. So it's a matter of identifying it and check those anomalous behavior pieces. 0 day was all about when it's going to get patched. You know, you got X number of days before it happens, and so now I get a chance to, I know this series of addresses throughout the world. Before the patch hits, I can do what I have to do or want to do. In the piece of mutation, what's interesting is kind of that whole theme. Denial of service attack's been around how long? And we're still having the problem. Ages. So you think $5 billion we'd solve the problem. So, but what happens is they've changed and their methodology has changed to a piece. And so it used to be just flooding the network so that the processors basically go on comatose and everything floods in. Well, now they're going into, they get to the point of the app servers, kind of do the same thing, into that kind of state. And so that whole thing has changed. So it's a matter of being able to keep up and understanding those. That's a whole different layer. So if you didn't have aspects to that, didn't have the known component to be able to identify and block it, it would continue on. And that's really what happens. So the aspect of the upper layers being able to be identified in part of the inspection process. Lookups, you know, everything in flux type of thing that goes on, redirections. And I think in the VM world is, I think one of the, with everything going to a cloud, being able to move from one app, one guest, to another guest horizontally inside is going to be, I mean, it's already there. The question is do we have the tool sets to really identify and see it? It's becoming now public knowledge, I'll put it that way, because they're understanding it more, and you'll see more. People will have the skill sets and to actually do it. But, for example, has anybody ever realized how many things that come out of Gmail or out of the other host providers? Sometimes it gets pretty astonishing. And so there are pieces that they're all missing because they weren't looking for it. They didn't have the skills or the tool sets to be able to do it. And I think the horizontal piece in the VM world, even in a client base, is going to be, in some cases, it's another area, it'll be a challenge to be able to get that piece to understand and the metrics to identify a block, et cetera. And it will take some type of intelligence to be able to accurately and effectively do that for those speeds and those areas. So one of the things I always tell everybody, make sure you look at your SLAs. So, and it's going to get more specific. It used to go, we put our device, for example, behind a lot of different, in front of us, and so we come back and hear what you get, right? What's really becoming interesting, you used to see 10,000 events and et cetera, and in those you would have a very high degree that it was very specific for a particular style of attack. And today, you're finding the most severe attack has 2 or 3 hits within that time frame. So they become very stealthy, very pointed, and it's a matter of being able to identify that particular thing. Let's see if here's. Okay, so skirted around what is intelligence? What's intelligence? The real key in the mainstream description is it's got to be abstract, thought, communication, has to learn, you have to have memory, you have to have the ability to problem solve, reaction time, you have to understand, it's intelligence, it's quotient, all those characteristics, okay? So under the intelligent abilities, you've got to know what's out there, and be able to detect the unknown and never before seen. You have to understand the complex ideas. We've got to adapt to whatever type of attack that's coming and be able to identify if it's good or bad. We have to learn from the experiences. We have to gauge in reasoning. We got to analyze in total how they interact with each other, not just independently within each other and the cause and effect of it. And then we have to keep a database current and up to date because things are going to get faster. Whatever happened and took 4 days is going to take 4 hours. Whatever took 4 hours, it may be instantaneous as things happen. So the analytic piece to this is going to have a real data set, just like any big data environment. Instead of batch, we got to move it to a real time and use the components to identify very effective and accurate and fast if this should be allowed or not. In the area of the algorithms, if someone comes to you and says, well, we're intelligent, and they say, the next question should be, what are you using? If they're using just Bayesian, they're not close. So in any data set, real data set world, it's a matter of massaging the data set, having an accurate, effective, and up-to-date data set, and making sure that the various pieces are put together to get an accurate outcome. It's not just about its smoothing, it's relational, it's a variety of aspects that have to come together in a series of algorithms. And we can actually put those together in a layered fashion and we can inspect. The other part of this has got to be fast, real time. I'll inject a little bit about, in our case, we're taking the process comes in, inspects, and we react in 11 microseconds. So we're getting to the point, everything coming together where you can actually get the speed to do that. And so now real-time analytics on the fly can and be part of the security solution. And it will move down to the client side as well. So what is it not? It's not sandboxing. Sandboxing pulls it off, uses the VM, looks at the behavioral piece. The problem is it's not sustainable. It can't sustain large speeds. It's not necessarily real time. Another aspect that's happening is people say, well, is a threshold. We can use thresholds as an example. We can use those as a sensor. So what if, for example, a threshold comes in and all of a sudden you have a spike in the line rate. Jumps up to 3 megs and it's always down to 1 meg or whatever the case may be. Well, that's a situational piece. That may be good, it may be bad. So let's use it as a sensor and feed the algorithms to be able to determine accurately, and part of this is being able to see if it's never seen before, and has it historically or behavioral make sense. And command and control. There's a group that's using command and control is if I can understand the command and control, I can dismantle a bot or not make it effective because it has to have a command and control to be able to tell it what to do and march on. That is a step, and it's a good step, but it's also, and then what if we could use that as a sensor? So now that we can find where it's going, even though bots may be well distributed and relayed off of someplace else in the world, but we can see some of those patterns and we can learn from it. What if they change from a particular address to the next address? Can you detect it? Is there some line script in there somewhere that actually changes something? Does it have a different file name? Does it have an extension, etc.? All those little pieces that come down there, you can feed in and we can use algorithms and analytics to be able to determine if that should go forward. So like I say, it's better, but also a number of the people are also in the sandbox. But it's not going to be, I think, the end game. It's another tool. It's better than it was before, but it doesn't sustain the real time. So the deficiencies in it end up into, which is even, we'll go into other areas, is the fact that the attackers now can identify what you're using to identify them. So in the case of sandbox, they can determine if there's a sandbox there. And we'll talk about in the VM world as well, is what tools are there, so they can determine what they're being identified at. Sandbox is one of them. Is it out there? Other codes. Want to get around sandbox? Let it sit to the side for 31 days, 32 days. It wakes itself up, goes on, takes the system clock check, etc. Off it goes. Sandbox won't remember it. And I think the biggest piece to it is the ability to do real time. People want to be secure, but we also we do not want to give up our user experiences. If we have to wait, we have to be redirected. If we have to do an operation, all I want is my information that I want now. That's it. So that part of the real time is really important. So in the world of intelligence, it's all about the algorithms, it's all about the sensors. And the sensors are really multidimensional, multi-locational. You have to find them in all the different layers, all the different traffic types, and be able to, then the algorithms, be able to put it all together. So what you would do in a normal security world with people now becomes an automated process. And to many, that's very scary because we're giving up control. You know, what if we have a false positive? Well, in some cases we can learn from it. The key to it is getting the accuracy. So fine-tuning all this stuff. And that's what's on the horizon. So, in a nutshell, by listening, I just use kind of a quick little, what do you do? Well, we listen, learn, predict, react very fast. So every one of these pieces will have a sensor to be able to see the behavioral piece to it and add to the algorithm. So we're looking for some of this. So whether it goes off a unique port, if it changes different port for the application on the fly, whether it is a certain type of HTML, if the GET request is different than expected from what I anticipated, if the signature, et cetera, is different, if the graphic content is different, if the image is now, instead of grayscale, it happens, or flesh tones, it's a darker flesh tone as opposed to lighter, those type of things. All of those change factors could be put into a censoring device, and we can also have to take in the fact, and then there's one piece here, is the known spammers. We have to ask the piece of what is known, what is the baseline. So part of the network behavioral analysis piece is, well, what's the baseline? What is the baseline for each and individual organization in the network? So that becomes a baseline, and then we can learn from it and the anomalies around it. We can also take a look at how the host communicates to the guest. Synchronization. How does it sync up? What's the patterns? Is it always there? What if it changes? What if the pointers change? What if it goes to a different part of the registry? What if the registry says it's been redirected? What if it's higher or lower? All these pieces, again, can be put together and get a consensus. Memory allocation. Where does it go? So, does it work? In every one of these particular cases, the MyTab, Storm, these are all attacks of the year, if you will, going back maybe the last 7, 8 years. But every one of those have now mutated. Configure has mutated. MyTab mutated, Storm mutated. Each one had their own little attributes, and they all obviously get around what they had. So APTs, Advanced Persistent Threats, they're starting to look like a Zeus and all the other things, and what they did is basically lay dormant for a bit. Tor hides some of the attributes in routing and et cetera. One of the pieces that can be put into the guest OS and feeds into the network layer in the VM world is to be able to take in these knowns, and we take the baseline. We can take what we know from sensors from all over the world, a different list space, add those to that, and now there's a baseline, and that's done everybody updates maybe 10, 15 minutes. The problem is you never know when those are going to hit the list. For example, we've experienced this. We had, in fact, it was about 7 years ago, and it continues on today. MyTab. University of Minnesota had a server that had been compromised, and it was after this school system. School system says, we're blocking it. How come? We called up and looked at, there was a version of MyTab that was not on any list from any of the AV vendors. And we get about 70 of them. So they either hadn't seen it or hadn't put a fix to it. What they started to do was, in about 4 days, you started seeing signature and definition issues come out, as well as up to maybe 3 months. So the unknown becomes known, but is it fast enough? So update. And so we use the intelligence to be able to bridge that gap. And at the edge, or even on the desktop, it's going to have to be real time. Milliseconds will not cut it. It's got to be microseconds. Again, the user experience. So, okay. I'm going to give you a series of characteristics of a particular virus. And I want to see if you can all name it. Okay? So it begins in exploits in Microsoft. By the way, we're timing. It spreads over LAN using a USB memory stick. It has 297 subroutines, propagates to the DLL. PCs are turned to drones and the botnets that it reaches out to. There's 7,000 domains, and only a certain portion of them are active. They craft an RPC request and eventually sends a message to an open local using UP. Has a backdoor with random higher order ports. And you can see the random port numbers. And it first searches for blocks of 250 domain names and operating systems. What's the name of that attack? Huh? Configure? Yeah, it's a version of Configure. Absolutely. Yeah, and it's an interesting because it is mutated and very fast. What used to take several, like 6, 7 months, is now mutating about once every month. So, good. That's what experience does. So, good one. But in that whole piece, the whole part of that is being able to identify those things using algorithms and intelligence. And if those things are in place, I suggest to you that we can identify that within microseconds and not allow someone to lose their weekend and watching the Super Bowl. What's that? See the whole week? Yeah, yeah. We've got cases where, and I'll show a little bit later, but once inside, it's pretty difficult to stop it still. And you may have repercussions of that for several months, where it now becomes horizontal. It's one of those that starts going horizontal, and just about the time you think you got it nailed, something pops up. Yeah. 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 We have a $1 billion company that we put in, basically, we put our device into like a forensics mode, and they didn't tell us. And so we actually found it and located and isolated it. But it's very difficult, and that's not even one of the newer ones anymore. So they become very stealthy. Any other questions? Now on the client side, it's becoming BYOD. So your point earlier is that it's really the boundaries of and entrance points become seamless. It's one big network, reality. So somebody puts out a huge BYOD project, next thing you know, you got 12,000 antennas. Why 12,000? Well, that's the number of devices out there. But reality is, every one are going to go to a app. They're going to download things. In today's world, the app world, whether it's an Android or whether it's the Apple Store, there's a lot of malware sitting out there just waiting on an app, just waiting to be downloaded. So now, as these things, you can bring it down from an administrative piece, bringing it down very tight, but there's always going to be somebody that says, I want that app. So how do you legislate? How do you enforce those or get those type of behavioral things through? It's very difficult. But so the question is do you need to? So if there's a way to have the device home through and actually into an intelligent device, regardless of where you're at, can I now use that? And if I see an app that has identified an app, it's scrubbed through, that has some type of malware on it, we'll say in general terms, is now can I learn from it and now put it so that everybody else out of those 12,000 devices are not, or 11,999, are not going to get it. Because you never know when they're going to hit enter. You never know when they'll drag it down. So the answer is yes, it can be done. And of course you want the standard analysis piece. You want to be able to have the metrics to it so that you can trace it. You need to have it put together so that it has, the processes hasn't disrupted the flow or changed an order. Who knows? You may have a forensics case and a dispute on your hand. And we've gone through that, where all of a sudden we had an inside employee who was a visa holder who was downloading information, and it's also happened using in the app world, and then resending things out to another country, turned out to be intellectual property. So now, is that admissible in a court of law? So making sure that the process is spot on, so it's not altering, change the string. The NAC is part of it. It can be, depending on the device. Encryption can be part of it, depending on. Each has its benefits. We all know that. Each has some vulnerabilities. So the next part of all this is how can I share? Whether you're just in your own organization or can I share through the world with the fact that I just found it. Now there's a number of companies that are trying to find and put sensors throughout the world to find where these things are. So when an attack comes and it's first 50,000 PCs or 50,000 networks, whatever is, can we identify it and when we quickly put a patch and put a protection up and then redistribute it? Well, we found out that that is becoming very difficult because it was fine when the attacks were mutating in 6 and 12-month increments. When they're mutating in days and hours, it becomes more problematic. So the question is is, in a broader scheme of things, is can I redistribute the known that I just found, high degree of accuracy, can I redistribute that to a community to be able to now protect themselves? And we can do it very fast, but it has to be accurate. So that's the other part of the piece of this whole intelligence side, is once you find it, now everybody becomes a sensor. So in essence, not only has this become very powerful, as a lot of old PCs and et cetera, now it can become a sensor to detect and find the next attacks so that we can stop the spread much sooner than we ever were before. So we can take some of all these componentry and put them into the VM world, and at the network layer we can use that as a monitoring area and take those attributes, so that communication paths, those interactions within that whole structure, we can now use that. We have visibility, so once we have visibility, we can have actionable items. And we can use the various components that go with it. So any phase of the attack has these combination: recon, probing, attack, payload, delivery, and exploitation. Even the aspect of crisis, which is in the VM world, is just quickly mapped it out, what it looks like in the characteristics and what it does. The process, downloads an Adobe Flash installer, inserts a certain type of file, it can spread. So the installer becomes, you can see that there are certain attributes to it: byte size, checks, etc. Rootkit. By the way, it's interesting, the size. I mentioned here in a little bit, but portable executables, even down to that type of componentry. We've actually found portable executables down to 133 bytes that were part of that small, down to a part of an attack, as just a sequential part of an attack. So even these type of things are becoming not just one 4,000 bytes blurb, they're becoming fractured at different times and then collect themselves. So the censoring piece to this gets pretty unique when you get down into those type of size functions. And we can also take the I/O ports. That becomes part of the censoring devices. But even in the bot world, they're changing so fast that people are realizing that these things are thousands a month, mutated and changed that they've never seen before. So it's going to take something that goes beyond just a traditional list to actually to understand and get these. So we're running on them. I'm just going to move forward a bit, and this is going to be posted. If anybody wants more detailed discussions, etc., please let me know. Again, I keep it general because of some of the issues I mentioned earlier. We can also detect Zeus, and here's some of the command control functions and etc. that they go on, so being able to identify that. Blue pill, subvert, we're all part of aspects in the VM world. And I mentioned APTs, advanced persistent threats, and walked through what those particular threat vehicles are and how they work with the remote access tools and key loggers, denial of service attacks. So everyone that used to be, again, little individual attacks now have been put into a complete class and category. And at the end of the day, what we're really looking for, the big X is gone. It's very difficult to even find these things without the right tool. In fact, a lot of times I put up and said, anybody hear anything? Anybody see anything? You realize there might have been a hack that just went through? If you don't have the right sensors, even in a wireless world or in the other world, you're not going to be able to catch it. So it's about the sensors. I'm just going to move through. It's the anatomy of this whole thing. So this is the case where this particular company had a version of Configure that a year ago, and it's still fighting. So we end up finding events with various products in front, and we're able to identify it. So it does work. Any questions?
How does the technology work? What is it? How do you do it?
How do we do it? We basically we have a series of sensors that use traditional parts within the OS layer that feeds back, and we learn from that, and we have a series of algorithms that inspect. So the process becomes, traffic comes in, we inspect it for known events. If it's accepted, we move to, it goes to the intelligence piece, layered of algorithms, accept or deny. And we put, if it's rejected or identified, it goes to a database of key elements.
So sensor meaning your network sensor, or is it sensor on the endpoint?
It can be both.
Okay, so then I'm wondering, can you integrate with existing standardization work, such as an integrity measurement collector of a TNC client, for example? I mean, I'm just wondering, how does this fit into a more standardized ecosystem?
Every aspect has a rhythm. Stucknecks, whether it's the SCADAs and all of those have a rhythm. They have certain protocols. They have certain methodology.
What is critical is to proliferate that information, and this intelligent sharing, threat response has to happen on multiple levels, and
it's true.
Has to really distribute to the architecture, right? So how do you integrate with security protocols and intelligently communicate on a security layer with all the relevant players, right, to do policy enforcement, policy decision, to do all this orchestration. I'm again concerned that this is a vendor-unique technology. I mean, I think this is great, but I think you should look into working with other standards groups to integrate these technologies.
Well, I don't disagree with you. I don't disagree with you. I agree. And I think that day's coming. That day's coming. Absolutely. There's no doubt.
So I'm really thinking to integrate this stuff into the integrity measurement of a TNC client, for example.
Exactly. Absolutely. Yep. Yep. Any other questions?
Last question. One last question.
Thank you. I appreciate it.